This is the second section of chapter 2, which is on correlation, and this section is Spearman's rank correlation coefficient. Now, it's a different way of calculating the correlation coefficient. Now, we use it when our data is ranked, let's say in order of preference from first to 10th, for example. The data is not normally distributed, so it's a type of data that we find wouldn't be normally distributed, like height and weight, that type of thing. And the data has a non-linear relationship. So we only use the PMCC when there's a linear relationship, when we suspect there's a linear relationship. When we know it's non-linear, then we'd use Spearman's rank. Now, just like the PMCC, the value of Spearman's rank can be anywhere between 1 and -1. And the way we interpret it is that if we get a value of 1, it means that there's perfect agreement between the rankings. So let's say we've got two judges and they read, let's say, 10 books each, and they both agree exactly on which one they like the best and which one they like second and third and so on, up to the 10th one, then we'd get a Spearman's rank of 1. If there's no correlation between the rankings, so if they were total disagreement about which one they thought was the best one, the second best, third best, and the worst, then we'd get a Spearman's rank value of 0. If we get a Spearman's rank value of -1, then it's the exact reverse order. So if judge number 1 thought that book A was the best, that means that the other judge thought that it was the worst. So it's the exact reverse order. So we can use the value of Spearman's rank to then interpret it as we get this value between 1 and -1. So now we're going to go through the method of finding Spearman's rank correlation coefficient. Okay, so the first thing we're going to do is to rank the data values by numbering them. Now, if we find that we've got 2 or more data values that are the same, then we assign a mean ranking to them. So here's an example. Let's say I've got these 4 values and I want to rank them from the smallest to the largest. So this would be rank number 1 because it's the smallest, rank number 2. Now I've got 2 4s, so I'd probably do this, rank number 3, rank number 3, or sorry, rank number 4, and then rank number 5. But these 2 numbers here, the 4 and the 4, they're both the same, so I can't rank one of them 3 and one of them 4. What we do is we find the mean of 3 and 4, and that's what we give or assign a rank to that number 4. So I've got these 2 numbers which are the same, which would have different rankings, which is not allowed. So I've used rankings 3 and 4 for 2 different numbers. The mean of that is 3.5. So what we do is we assign a rank of 3.5 to both of those 4s. So effectively we've got rank number 1, rank number 2, 2 numbers that are ranked 3.5, and then rank number 5. Next thing that we do is that we find a difference, which we call D, of the rankings of our sets of data. And then lastly, calculate Spearman's rank using this formula. Now we use R sub S to represent Spearman's rank to differentiate that from the PMCC, which is this R. And we do 1 minus 6 times by the sum of the differences squared. That's to ensure that they're all positive. So these differences that we've worked out, the differences of the rankings, we square it, we find the sum of all those differences, we times that by 6 and divide by n, which is the number of observations, like the number of pairs of values, times by n squared minus 1. So this is the number of observations. And then once we've worked it out, we can then make some sort of comparison on our result, or make some sort of comment on the value that we get at the end, remembering what those values mean. Example 3. 2 tea tasters were asked to rank 9 blends of tea in order of preference. The tea they liked best was ranked 1. Their orders of preference are shown in this table here, and what we want to do is to calculate Spearman's rank correlation coefficient for these data. Now, it'd be much easier if we had a table that went down rather than across. So what we'll have in our first column is the blend. Then we're going to write down taster 1's ranking. Then we're going to write down taster 2's ranking. And then we're going to work out the difference between those rankings and then the difference squared. So let's get that table filled in. Okay, so here's that information in that table. So the first thing we're going to do is do taster 1's ranking or score minus taster 2's ranking or score. And that will give us D. So 3 minus 5 minus 2, then 0. 2 minus 4 is minus 2. 8 minus 2 is 6. 5 minus 7 is minus 2. 9 minus 8 is 1. Then we have minus 2, 1, and 1. Now we're going to square those. So I'll have 4, 0, 4, 36, 4, 1, 4, and sorry, this one should be 0 here because it's 1 and 1, so that should be 0. So that means that this is going to be 0 and this is going to be 1. So now what we want to do is to find the sum of all those differences squared. So it's going to be 4 plus 4 plus 36 plus 4 plus 1 plus 4 plus 1. I've left the zeros out. That gives us a value of 54. And we know from the question where it says that they rank 9 blends of coffee, or we could just count the number of different blends, number of columns, that will give us n equals 9. So now that can go into the formula. So Spearman's rank is going to be 1 minus the sum or 6 sums of d squared, so that's 6 times by 54, divided by n, which is 9, times by n squared minus 1. Now it gives us 11 over 20, which we could change to a decimal, so 0.55. So if we needed to interpret that, so all of those can go into the formula. They will give us this value, 11 over 20, or 0.55, which is telling us that there is some sort of agreement between their rankings. Not particularly strong, but there is some sort of agreement there. Example 4. During the cattle show, 2 judges ranked 10 cattle for quality according to the following table. Find Spearman's rank correlation coefficient between the 2 judges and comment on the results. The first thing we're going to do is just do or rewrite this table so it goes down rather than across. Okay, so here we go. The table's now going down. So let's fill in the differences. So 1 minus 3 minus 2, 5 minus 6, 2 minus 2, 6 minus 7, 4 minus 5, 8 minus 8, 3 minus 1, 7 minus 4, 10 minus 9, and 9 minus 10. And now we're going to square those values. So we'll have 4, 1, 0, 1, 1, 0, 4, 9, 1, 1. Now we're going to find the sum of those differences squared. So it's going to be 4 plus 1. I'm going to leave the zeros out. Plus 1 plus 1 plus 4 plus 9 plus 1 plus 1. That gives us a value of 22. So now we're ready to work out Spearman's rank. So it's going to be 1 minus 6 times by the sum of those differences squared. So 6 times by 22. Then we want the number of observations. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10 in this question, 10 observations. So it's going to be 10 times by 10 squared minus 1. So this works out to be 1 minus 2 over 15, which is 13 over 15. Let's press the SD button to see what we get. So we get 0.8666 recurring. So let's go for 3 significant figures and we'll write down our value as 0.867. So that's 3 significant figures. So now we've worked that out, we want to make a comment on our answer. And I'd probably say something like there is a good or even strong agreement of the ranking of the judges. And we could go on to say something about where the judges quality, the catalogue quality. Well, I suppose we don't really need to. Example 5. The marks of 8 pupils in French and German tests were as follows, and they're here in this table. Use the formula for Spearman's rank here to find estimate for Spearman's rank correlation coefficient, showing clearly how you deal with tied ranks. Now, because we've got tied ranks, that's why this becomes an estimate rather than the exact value. Give your answers to 2 decimal places. So we've got this table that's actually going across. It'll be much more useful if we do the table going down. So all the information now is going in a table going down. You'll see I've added 2 extra columns here. This is where I'm going to put the rank for the French scores and the German scores, and I'm actually going to rank from smallest to largest, smallest to largest. Now you could rank largest to smallest. You would still get the same answer, but I'm just going to do smallest to largest. So if I start with French, I can see that the smallest French score is 1, so that's going to have a rank of 1. Then I have 33 comes next, so that's going to have a rank of 2. Then 46 down at the bottom here, that's going to have a rank of 3. Then at the top we have 52, so that's going to have a rank of 4. And then 54 will have a rank of 5. Then you can see we've got 2 55s. So we're going to rank those 6 and 7. That's going to have a tied rank in a minute, and 86, 8. So I need to show the working for this tied rank here for the 2 55s. So I just need to show that I do 7 plus 6 divided by 2. So it's going to be 7.5. So now these two are going to have a rank both of, not 7.5, sorry, 6.5. So change that to 6.5. And we'll put that down here. So 6.5 and 6.5. So these will be the actual values that we'll use. I'll just cross those there. Right, so now let's move to the German column. And again, we'll find the lowest score, which happens to be the 34. So that's going to be 1. And then 39 is rank 2. And 40 is rank 3. And then, we've got another 40 there. So that's going to be a tied rank there. So we'll put 3.5 of those in a moment, but we'll carry on. So rank number 5 will be 48. Rank number 6 will be the 57, and then 7 and 8. So again, we're just going to show our working to show that we've got a tied rank here for the 2 40s. So that's going to be ranks 3 and 4 divided by 2. So we need to put in there ranks of 3.5 for both the 40s. So 3.5 there and 3.5 here. And it's those tied ranks we're going to be using to work out D. So let's work those out now. So we'll go down the table and work out the difference in those ranks. So we have 4 minus 3.5, so 0.5. 1 minus 5, so that's minus 4. 8 minus 8 is 0. Then minus 4, 3, 4.5. Then negative 2 and negative 2. And now we're going to square those. So 0.5 squared is 0.25. Then 16, 0, 16, 9. 4.5 squared on our calculators gives us 20.25, and 4 and 4. So the next thing we're going to do is to find the sum of our d squareds. So we'll add those up. So that gives us 139 over 2. 139 over 2, which is 69.5. Right, so now we can put these into the formula. So I have 1 minus 6 times 69.5 divided by, now we have n equal to 8 because it's 8 pupils. Not sure if I wrote that down anywhere. Just write it down here. N equals 8. So I have 8 times by 8 squared minus 1. So that gives us 29 over 168. And we'll give that to 3 significant figures. So that's actually 0.17261, like that. So let's give our answer to part A up here as 0.173. So that's to 3 significant figures. Oh, actually, no, it says give your answer to 2 decimal places. So actually 0.17 is what I should write down. Let's do that instead. Let's read the question properly. So 0.17. Okay, right, let's move on to part B. It says, without recalculating the correlation coefficient, state how your answer to A would change if pupils H's mark for German was changed to 38. So pupil H's German mark, pupil H German mark, there it's 34. So what if that was changed to 38%? That's the question. Does that change my answer? And we're not going to actually recalculate it. So we're talking about this score here. Now, if this was changed to 38, it would still be ranked as 1 because it's still the lowest score. That would mean this value rank wouldn't change. This wouldn't change. This wouldn't change. So overall, nothing will change. So I need to write that down. So no change since its rank would not change. And if the rank doesn't change, then D doesn't change, D squared doesn't change, and then the formula doesn't change. Okay, let's have a look at the second part of part B. A 9th pupil was included who scored 95 in French and 89 in German. So let's write that down. Let's say we had this student here that got 95 in French and 89 in German. Right, so if they got 89 in French, then they would be ranked 9th here. And if they got 89 in German, that's the highest score, they would also be ranked 9th here. That would mean D is 0, D squared is 0. Okay, so that would mean that the top part of my formula here would not change. But this part would change because N is now 9. So I've just written that down. Since it would be ranked 9 in both subjects, D would not change, only N would change, so that would go to 9. So what would happen is this top part of the fraction would remain unchanged. This part of the fraction would get bigger, which means this fraction would get smaller. So we can finish off that with saying that at this part, the N times by N squared minus 1 would increase down here, which would mean this whole fraction would decrease, meaning RS would increase. Spearman's rank would increase because we're taking away a smaller fraction because that denominator is getting larger. So let's move on to part C. So part C says a teacher collects extra data from other students in the class and finds that there are now many tied ranks. Describe how she would now find a measure of correlation. So we would probably suggest using the PMCC, since this type of data we'd expect to be normally distributed, and we'd expect some sort of linear relationship between the two sets of data. So I've put that down there. So since the marks would be normally distributed, so remember when things are not normally distributed, we would use the Spearman's rank, and we have a linear relationship. So again, if we didn't have a linear relationship, we would use Spearman's rank. So we'd expect there to be some sort of linear relationship between the two. We would calculate the PMCC. And the reason we know that there's a linear relationship because of the number of tied ranks, which means that they're ranked the same in both subjects, which would suggest some type of correlation. That is, could be positive or negative. It looks like it could be a positive correlation, but tied ranks means that the same type of score or ranking in French and German. So yeah, when that happens, we'd use the PMCC. So you should now be able to do exercise 2B on pages 30 to 32 of the textbook.